Good morning, dear students. Welcome to physics class of P1. So in the previous class, we have discussed the introduction part about the chapter, the laws of motion. I have given the brief introduction about the what is force, what is linear momentum, right? What is inertia? That means what the Newton's laws of motion we have studied. Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. Newton's first law of motion states what every body is continues to be in the state of rest or uniform motion unless it is compelled by some external agent, that is called as the force. And the Newton's second law of motion states what the rate of change of momentum, right? The rate of change of momentum is directly proportional to the applied force, and it takes place, the change in momentum takes place in the direction of the applied force, right? And Newton's third law of motion, Newton's third law of motion states to every action there is equal and opposite reaction. We have given some examples for this. So rate of change of momentum, from the Newton's second law of motion, what we state here, the rate of change of momentum is directly proportional to the applied force, right? Now momentum change ಮಾಡ್ತೀವಿ, right? Changing ಜಾಸ್ತಿ force apply ಮಾಡಿದ್ರೆ ಜಾಸ್ತಿ momentum change ಆಗುತ್ತೆ, right? That is what the Newton's second law of motion states here, right? Momentum is nothing but what the quantity of motion contained in the body, that is measured by the product of mass into velocity. So with all those basic discussion, now here we have to discuss the law of conservation of linear momentum. Law of conservation of linear momentum we have to discuss here, right? When a force is acting on a body, there is a change in the momentum. Change in momentum ಅಂದ್ರೆ motion log change ಆಗುತ್ತೆ, velocity increase ಆಗ್ತದೆ ಅಥವಾ velocity decrease ಆಗ್ತದೆ. ನಾವು force apply ಮಾಡ್ತೀವಿ, force increase ಆಗ್ಬೋದು ಅಥವಾ decrease ಆಗ್ಬೋದು. ನೀವು ಯಾವ direction ಅಲ್ಲಿ force apply ಮಾಡ್ತೀರಿ ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತದೆ, right? And the object is if you are applying the force in the direction of the motion, the velocity increases. If you are applying the force opposite to the direction of motion, the velocity decreases. Finally there is a change in momentum. But when a system consisting of a very large number of bodies, two or more bodies, what happens? There is a change in the momentum of all the bodies takes place. So in those cases what happens, if the system is free from the external forces, that is called as the isolated system, right? Isolated system means what here, which is the system which is free from the external forces, right? In those systems what happens, the net linear momentum of the system is always conserved or constant. That is called as what here, the law of conservation of linear momentum. The total momentum of an isolated system of interacting particles, right? The total momentum of an isolated system of interacting particle is conserved or constant. This is called as what the law of conservation of momentum. Likewise what law of conservation of energy, right? Law of conservation of energy, law of conservation of mass, right? So in this way again we are giving one more law of conservation of one more conservation law, that is what law of conservation of momentum. So the statement is what the total momentum of an isolated system of interacting particle is always conserved or constant, right? Let us take one example here. Let us illustrate and let us prove that the total momentum of the system is constant, right? Let us consider here the two bodies, the body A and body B, moving with initially of momentum PA and PB, right? We have the two bodies here A and B, which are moving with velocity with the momentum what PA and PB. The momenta of this body A and B are what PA and PB, right? Here PA and PB are the momenta, the initial momenta of the particles which are moving here. They are moving with initial moment of what PA and PB are the initial momentum before the collision. And what happens here, the two bodies will collide, dash or collide after in a short interval of time delta t. Delta t time these two bodies are collide. These two bodies are collide in a small interval of time delta t. After the collision, what happens? The two bodies get apart with a final momenta p dash a and p dash b. So ಇಲ್ಲಿ ಏನಾಗ್ತದೆ ನೋಡ್ರಿ, ಎರಡು ಬಾಡೀಸ್ ಇದಾವೆ which are called a and b. Initially they are moving with momentum what? pa and pb. Now momentum ಅನ್ನು ಯಾವ ಸಿಂಬಲ್ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ? p, and it is equal to mass of the body into velocity with which it is moving. So it is before the collision they are moving. So in a small interval of time delta t, these two bodies will collide. So collide ಆದ ನಂತರ ಏನಾಗ್ತದೆ ನೋಡ್ರಿ, according to Newton's third law of motion, the body B acts force on A and A acts force on B. Hence there is a change in momentum. Momentum do change ಆಗ್ತದೆ ಯಾವಾಗ body collide ಆಗ್ತದೆ, right? There is a change in momentum. Accident ಆದಾಗ ನೋಡಿರ್ತೀವಿ, ಎರಡು body ಬೈಕ್ ಆಗಿರ್ಬೋದು ಈ ರೀತಿಯಾಗಿ ಡ್ಯಾಶ್ ಆದಾಗ ಏನಾಗ್ತದೆ, ಮೊಮೆಂಟಮ್ದು ಚೇಂಜ್ ಆಗ್ತದೆ, ಅಂದ್ರೆ ಮೂವ್ ಆಗೋ ವೆಲಾಸಿಟಿ ಕಡಿಮೆ ಆಗ್ತದೆ. ಆವಾಗ ಮೊಮೆಂಟಮ್ದೊಳಗೆ ಯಾವ ರೀತಿಯಾಗಿ ಚೇಂಜ್ ಆಗಿರ್ತದೆ ರೀ, ರೈಟ್? when they collide with body B acts force on A and A acts force on B. So according to Newton's third law of motion, this FBA is equal to FUB, but they are equal and opposite. So after the collision, in this case what happens here? They collide B, the body A and B collides, B acts a force on A acts a force on B. So after the collision, what happens here? After the collision, in this case they get aparted with a velocity and with the final momenta, they move with the final momenta p dash A and p dash B. So collision ಆದ ನಂತರ ಏನಾಗ್ತದೆ ನೋಡ್ರಿ, ಇಲ್ಲಿ they collide and they get apart, ಅಂದ್ರೆ ಸಪರೇಟ್ ಆಗಿ ಹೋಗ್ತವೆ with a momentum, final momentum ಎಷ್ಟಿದೆ p dash A and p dash B. change in momentum ಆಗ್ತದೆ, ಅದ್ರ ಮೋಷನ್ ದೊಳಗೆ ಚೇಂಜ್ ಆಗ್ತದೆ, right? There is a, because of the force acting on the bodies, there is a change in the momentum, ಅಂದ್ರೆ ಮೋಷನ್ ದೊಳಗೆ ಚೇಂಜ್ ಆಗ್ತದೆ. ಅಂದ್ರೆ ಫೈನಲ್ ಮೊಮೆಂಟ ಎಷ್ಟಾಗ್ತದೆ collision ಆದ ನಂತರ p dash A and p dash B are the final momenta, PA and PB are the initial momenta, right? So then what is the change in momentum of A? So the change in momentum of A is equal to what? Change in momentum of A. Change in momentum of A is equal to what here? Final momentum minus initial momentum. Final momentum minus initial momentum. That is equal to what? P dash A minus PA, right? And what is the rate of change of momentum? Rate of change of momentum ಅಂದ್ರೆ time consider ಮಾಡಬೇಕಾಗುತ್ತೆ. Therefore rate of change of momentum, rate of change of momentum of A, rate of change of momentum of A is equal to what? P dash A minus PA divided by delta. So this is the rate of change of momentum of a body A. So collide ಆದ ನಂತರ momentum ದೊಳಗೆ ಏನು ಚೇಂಜ್ ಆಗ್ತಿದೆ, that is P dash A minus PA divided by dt or delta t. Similarly the rate of change of momentum of B, right? collide ಆದ ನಂತರ ಏನಾಗ್ತಿದೆ ನೋಡಿ, rate for body A, this one we have done. Therefore similarly rate of change of momentum of B, rate of change of momentum of body B is equal to what? P dash B minus PB divided by delta. So yes, to momentum change agidre, rate of change of momentum with time is what? P dash B minus PB divided by delta t. The final momentum minus initial momentum togolteve, right? And when the body collides here, during the collision what happens? This change in momentum because of what? Body B acts a force on A and A acts a force on B, right? Here FBA is what? FBA is the force exerted on B by A. Body B ಮೇಲೆ A ಎಷ್ಟು force act ಆಗಿದ್ರೆ collide ಆದ ನಂತರ, that is FBA. FAB is what? The force acting on A by B, because according to Newton's third law of motion, right? ಎರಡು ಕಡೆಯಿಂದ force act ಆಗ್ತದೆ. Therefore according to Newton's second law of motion, what we can write here? The rate of change of momentum, and you have to consider the Newton's third law of motion also. Newton's second law of motion, according to Newton's second law of motion, according to Newton's second law of motion, this change in momentum of A is what? It is responsible what? The rate of change of momentum the rate of change of momentum of A is depends upon what? The force acting on A by B. ಇಲ್ಲಿ ಎಷ್ಟು momentum change ಆಗಿದೆ ಅನ್ನೋದು ಯಾವ್ದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಐತ್ರಿ? ದ ಬಾಡಿ B, right? ಬಾಡಿ A ಮೇಲೆ ಎಷ್ಟು ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತದೆ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಐತಿ. That means what? The rate of change of momentum of A is equal to the what? The force acting on A by B. That is equal to what? FAB is equal to P dash A minus PB divided by delta T. Right? That is according to Newton's second law of motion. Again, FBA is equal to what? The rate of change of momentum of a body B is depends upon what? The force acting on B by body A. Therefore, this I can write here what? P dash B minus PB divided by delta T. Right? Now, this is we have written according to Newton's second law of motion. The rate of change of momentum is directly proportional to the what? The applied force. Right? Therefore, what we have written here? Rate of change of momentum is equal to force. In terms of force, we have written here. Therefore, what happens here? The force these FAB and FBA are, according to Newton's third law of motion, these two are action and reaction pair. One the action agidre, ಇನ್ನೊಂದು reaction agidre. One force act ಆಗೋದ್ರಿಂದ one body ಮೇಲೆ force act ಆಗ್ತದೆ. So similarly, that body also acts a force on this body. So therefore, according to Newton's third law of motion, what we can write here? FAB is equal to minus FBA. So according to Newton's third law of motion, these two FAB and FBA are equal and they are what? Action and reaction pairs. Right? These two are action and reaction pairs. So now we can write here this according to Newton's third law of motion, FAB according to Newton's third law. According to Newton's third law, this FAB is equal to minus FBA. Right? Their action and reaction are equal and opposite. So that's why we have written here minus sign. Equal, but minus sign indicates that they are opposite in direction. Now substitute here what? FAB is equal to what? FAB is equal to what? P dash A minus PA. P dash A minus PA divided by delta T. And this is equal to minus P dash B minus PB divided by delta T. Right? Now, just rearrange the term and simplify it. So what you will get? Delta T get cancelled on both sides. Therefore, P dash A minus PA, and this is equal to what? Right? This minus P dash B minus P dash B and minus into minus plus, it is equal to P. Just separate the terms here. I will take this PA to the right hand side and P dash B to the left hand side. So what it becomes? Right? P dash A plus P dash B is equal to PA plus PB. Right? So from this term, what we can write here? The total momentum. This is the total momentum after the collision. Right? So collision ಆದ ನಂತರ total momentum ಎಷ್ಟಿದೆ? ಎರಡು ಬಾಡೀಸ್ ಕೂಡಿಸಿ total number of bodies involved in the system, that is equal to what? P dash A and P dash B. This is equal to what? The total momentum after the collision. And P dash PA plus BB is equal to what? This is total momentum before the collision. Right? Now, this we can write here what? The total momentum after the collision is equal to the total momentum before the collision. Therefore, P dash A plus PB is equal to PA plus PB. So this is the important derivation what we have done here, right? The total momentum of an isolated system of interacting particle is conserved or constant. So ಈ ಕೇಸ್ ದೊಳಗೆ ಏನಾಗ್ತದೆ ನೋಡಿ, ಟೋಟಲ್ ಮೊಮೆಂಟಮ್ ಕೊಲಿಷನ್ ಆಗೋದಕ್ಕಿಂತ ಮೊದಲು ಎಷ್ಟು? right? P dash A plus P dash B is equal to PA plus PB. Total momentum after the collision is equal to the total momentum before the collision. And This is called as the law of conservation of momentum. So this is the very important derivation for 5 mark in the examination. They will ask a 5 mark derivation, right? State and prove law of conservation of linear momentum. So you have to take this illustration. With this illustration, you have to prove that the total momentum before the collision is equal to the total momentum after the collision, right? Now let us take one example for what the to explain the law of conservation of momentum, that is the recoil of gun, right? Now let us take one example for what this to explain the law of conservation of momentum. By considering the law of conservation of momentum, let us explain here for let us explain the recoil of a gun, right? Let us explain here what the recoil of a gun. So from the law of conservation of momentum, the recoil of a gun is the best example for what here the law of conservation of momentum. So what is recoil of a gun? Recoil of a gun ಅಂದ್ರೆ ನೀವು ಬುಲೆಟ್ ಫೈರ್ ಮಾಡುವಾಗ ಏನಾಗ್ತದೆ ಗನ್ ಬ್ಯಾಕ್ವರ್ಡ್ ಮೋಷನ್ ಅಂದ್ರೆ ಗನ್ ಬ್ಯಾಕ್ವರ್ಡ್ ಮೂವ್ ಆಗ್ತದೆ, ಅದಕ್ಕೆ ನಾವು ರಿಕಾಯಿಲ್ ಆಫ್ ಎ ಗನ್ ಅಂತ ಹೇಳ್ತೀವಿ, right? When a bullet is fired from the gun, what happens? A bullet moves in the forward direction and the gun moves in the backward direction, right? The backward motion of the gun is called as recoil of the gun. ಏನು ಬುಲೆಟ್ ಫೈರ್ ಮಾಡಿದ ನಂತರ ಗನ್ ಬ್ಯಾಕ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಮೂವ್ ಆಗ್ತದ, ಅದಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ ನಾವು ರಿಕಾಯಿಲ್ ಆಫ್ ಎ ಗನ್. ದಿ ಬ್ಯಾಕ್ವರ್ಡ್ ಮೋಷನ್ ಆಫ್ ದ ಗನ್ when it is fired, that is called as the recoil of a gun, right? The velocity with which the gun is recoiled is called as recoil velocity. ಅದು ಯಾವ ವೆಲಾಸಿಟಿ ಅಂದ್ರೆ ಬ್ಯಾಕ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಮೂವ್ ಆಗ್ತೈತಿ, ಆ ವೆಲಾಸಿಟಿಗೆ ಏನಂತ ಕರಿತೀವಿ ನಾವು recoil velocity ಅಂತ ಕರಿತೀವಿ. That velocity is called as what? Recoil velocity. And the velocity with which the bullet moves in the forward direction, that is called as the muzzle velocity. Bullet ಯಾವ ಒಂದು velocity ಇಂದ ಮೂವ್ ಆಗ್ತದೆ ಫಾರ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ, ಆ velocity ಗೆ ಏನಂತ ಕರಿತೀವಿ muzzle velocity ಅಂತ ಕರಿತೀವಿ. Now let us explain here the recoil of a gun by considering the law of conservation of momentum. Why the guns are made very heavy, right? So here the mass of the gun is denoted by capital letter M, and the mass of the bullet is denoted by small letter m. And after the firing, the bullet moves with the velocity v, and the gun moves in the backward direction with velocity v, that is denoted by the capital letter v here, right? So according to the law of conservation of momentum, the total momentum before the firing is equal to after the firing here, right? Total momentum is always constant, right? The total momentum before firing is equal to total momentum after firing, right? Total momentum before firing is equal to total momentum after firing. So total momentum before the firing ಏನದ ನೋಡ್ರಿ, before the firing gun is also at rest and bullet is also rest. So v is equal to 0, this v is equal to 0 and this v is also equal to 0. Therefore the total momentum before firing is equal to 0. The total momentum before firing is equal to 0. Therefore what is the total momentum after firing? After the firing, the bullet moves, so it has also velocity, and gun also moves in the backward direction. It is also a momentum. So ಎರಡಕ್ಕೂ momentum ಇರ್ತೈತೆ, gun ಅನ್ನು ಮೂವ್ ಆಗ್ತಾ ಇದೆ and bullet ಅನ್ನು ಮೂವ್ ಆಗ್ತಾ ಇದೆ. So we have the total momentum after the firing, we have to write here. So momentum is equal to what? Mass into velocity ಅಂತ ಬರುತ್ತೆ. So what is the momentum of the bullet after the firing? That is equal to what? Small letter m into small letter b. This is the momentum of bullet. And what is the momentum of the gun? What we can write here? That is capital letter M into capital letter B. Right? Now what we can write here? This M into B is equal to minus M into, just we have made the rearrangement in the equation, right? Therefore capital letter B, this is capital letter B, this is capital letter M, So then capital letter V is equal to what? The recoil velocity of the gun. ಒಂದು ಯಾವ ಗನ್ ಒಂದು ಯಾವ ವೆಲಾಸಿಟಿ ಇಂದ ಬ್ಯಾಕ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಮೂವ್ ಆಗ್ತೈತಿ ಅದನ್ನ ಕ್ಯಾಪಿಟಲ್ ಲೆಟರ್ V ಅಂತ ಬರ್ತೀವಿ. So minus, right, small letter m, that is the mass of the gun, mass of the bullet divided by mass of the gun. I have taken this m to the RHS, it comes in the denominator. Next, this small letter V is what? This is the velocity of the bullet, right? Now what negative sign indicates here? Negative sign indicates ಏನು ಮಾಡ್ತೀವಿ ನೋಡ್ರಿ, both this velocity, this v and this v are in opposite direction. ಎರಡು opposite direction ಗಳು ಅದಾವ ಅಂತ ಹೇಳ್ತಾರೆ, right? ಗನ್ ಬುಲೆಟ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಹೊರಟೆ ಅದರ opposite direction ಗಳು ಗನ್ ಮೂವ್ ಆಗ್ತಿದೆ ಅಂತ ಹೇಳ್ತಾರೆ. That is the negative sign indicator. But what point we have to see here, this the recoil velocity of the gun, recoil velocity of the gun is inversely proportional to the mass of the gun, right? It is inversely proportional to the mass of the gun ಅಂತ ಹೇಳ್ತಾರೆ. Why this is very important, right? recoil velocity ಜಾಸ್ತಿ ಮಾಸ್ ಕಡಿಮೆ ಇತ್ತಂದ್ರೆ ಏನಾಗ್ತೈತಿ, ಗನ್ನದ ಮಾಸ್ ಕಡಿಮೆ ಇತ್ತಂದ್ರೆ ಇನ್ವರ್ಸ್ ರಿಲೇಷನ್ ಅಂದ್ರೆ ಒಂದು ಇನ್ಕ್ರೀಸ್ ಆದ್ರೆ ಇನ್ನೊಂದು ಡಿಕ್ರೀಸ್ ಆಗ್ತೈತಿ, ರೈಟ್? ಈಗ ಮಾಸ್ ಆಫ್ ದಿ ಗನ್ ಇನ್ಕ್ರೀಸ್ ಆದ್ರೆ ಅಷ್ಟೇ ಏನಾಗ್ತೈತಿ, recoil velocity ಆಫ್ ದಿ ಗನ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತೈತಿ. ಇಲ್ಲ ನಮ್ಗೆ ಗನ್ ಸ್ಮಾಲ್ ವೇಟ್ ಇತ್ತು, ಅದ್ರ ವೇಟ್ ಕಡಿಮೆ ಇತ್ತಂದ್ರೆ recoil velocity ಜಾಸ್ತಿ ಆಗ್ತೈತಿ, ಅಂದ್ರೆ ಗನ್ ಜಾಸ್ತಿ ಸ್ಪೀಡ್ದಿಂದ ಬ್ಯಾಕ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಮೂವ್ ಆಗ್ತದೆ. ಅದಕ್ಕೆ ಗನ್ ಹೆವಿ ಆಗಿ ಮಾಡಿರ್ತಾರೆ, ಬಿಕಾಸ್ ಆಫ್ ವಾಟ್, ಟು ಗಿವ್ ದ ಸ್ಮಾಲ್ ಜರ್ಕ್, ಜಾಸ್ತಿ ಹಿಂದ್ಗಡೆ ಮೂವ್ ಆಗಬಾರ್ದು. ಮಾಸ್ ಜಾಸ್ತಿ ಇತ್ತಂದ್ರೆ ಏನಾಗ್ತೈತಿ, recoil velocity ಬ್ಯಾಕ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಮೂವ್ ಆಗೋದು ಏನಾಗ್ತೈತಿ, ಕಡಿಮೆ ಇರ್ತೈತಿ. ಅದು ದಟ್ಸ್ ವೈ ವಾಟ್ ದ ಮಾಸ್ ಆಫ್ ದ ಗನ್ ಈಸ್ ವೆರಿ ಹೈ. ಸೊ ವೈ ಇಟ್ ಈಸ್ ಮೇಡ್, ಬಿಕಾಸ್ ಆಫ್ ವಾಟ್, ಟು ಗೆಟ್ ದಿ ಸ್ಮಾಲ್ ಜರ್ಕ್, ಅಂದರೆ ಬ್ಯಾಕ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಜಾಸ್ತಿ ಮೂವ್ ಆಗಬಾರ್ದು ಅದು ಫೈರ್ ಮಾಡುವಾಗ. ಸೊ ಅದ್ರ ಸಲುವಾಗಿ ಗನ್ ಹೆವಿ ಇರ್ತದೆ. ಕಡಿಮೆ ವೇಟ್ ಇತ್ತಂದ್ರೆ ಏನಾಗ್ತೈತಿ, ವೆಲಾಸಿಟಿ ಜಾಸ್ತಿ ಆಗಿ recoil velocity ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. ಸೊ ಅದನ್ನು ಕಡಿಮೆ ಮಾಡೋದ್ರ ಸಲುವಾಗಿ ಏನು ಮಾಡಿರ್ತಾರೆ, ಗನ್ ವೇಟ್ ಜಾಸ್ತಿ ಇರ್ತದೆ. ಸೊ ದಿಸ್ ಇಸ್ ಎಕ್ಸ್ಪ್ಲೇನ್ based on what, the law of conservation of momentum. So the recoil of a gun is the best example for the law of conservation of momentum. So again you can give the many examples for to explain the law of conservation of momentum, right? One more example I can give here for the law of conservation of momentum. That is what the rocket propulsion, right? You all know that to carry the artificial satellites to the suitable height above the surface of the earth, right, for placing in an orbit around the earth, that rocket is needed, right? Rocket ಅನ್ನು ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಏನು ಮಾಡ್ತಾರೆ, ಆರ್ಟಿಫಿಷಿಯಲ್ ಸ್ಯಾಟಲೈಟ್ಸನ್ನು ಅರ್ತ್ ಆರ್ಬಿಟ್ ಒಳಗೆ ಲಾಂಚ್ ಮಾಡಿರ್ತಾರೆ. ಸೊ ಟು carry these processes, rockets are used, and this rocket propulsion is based on the what, the principle of conservation of momentum. The principle of conservation of momentum is also used in case of what, the rocket propulsion. There also the principle of conservation plays a very important role in case of rocket propulsion. So this is a very important point what we have discussed today, is that is about the law of conservation of momentum with examples we have discussed here, right? in the next video class we will discuss about the next point related to the what, the laws of motion here, that we have to express we have to explain about the equilibrium of particles, and we have to discuss the common forces in mechanics, that is about the friction we have to discuss here, right? After that the rolling motion, so that is a circular motion, centripetal force and centrifugal force we have to discuss. So we will continue in the next video class with the next related points. So prepare this, the derivation, that is what the law of conservation of momentum. Law of conservation of momentum prepare madre. This derivation is important. This derivation is important for 5 marks. Many times they have repeatedly they have asked this state and prove the law of conservation of momentum for 5 marks. Okay. Prepare this. We will continue the next point in the next video class. Okay, thank you, students.